We're on problem 49. Let me copy and paste that. Copy and paste it into the window. You have copied it. And now let me paste it. There you go. Problem 49. Let me pick a good highlighter color. Magenta is good. A student showed the following steps in his solution to the equation below, but his answer was not correct. And then at the bottom they say, in which step did he make his first error? So let's see. Log base 5 of 2x squared minus 3x plus 1 minus log base 5 of x minus 1 plus log base 5 of 125 is equal to 6. Fair enough. All right, now it looks like in this first step, he kept this the same. Can't mess up there. And then he said log base 5 of 125 is 3. Yeah, that's right. 5 to the third power. 5 to the third power is equal to 125. So that is right as well. And let's see. Here, it looks like he took the 2x squared minus 3x plus 1 and he factored them into 2x minus 1 and x minus 1. Let's see if that's right. 2x times 2x is 2x squared. 2x times minus 1 is minus 2x. Minus 1 times x is minus 3x. And you have a minus 1 times a minus 1, you get a plus 1. So you get 2x squared minus x minus 2x, so minus 3x plus 1. So this is right. So far, so good. What does he do next? All right, in the next step, he keeps this first term, he keeps the same, 2x minus 1, x minus 1. Fair enough. And he keeps this term the same. And he just subtracts 3 from both sides. He subtracts 3 from both sides, and this becomes 0, and then this becomes 3. Fair enough. And now what does he do in the next step? This is interesting. He then says that log base 5, let's see, he essentially said, if I am subtracting two logarithms with the same base, that's the equivalent of dividing the two things. So he kind of did a quick step here. So his logic here is if that log, I don't even have to write the base 5, but log of 2x minus 1 times x minus 1 minus log of base 5 times x minus 1, that would equal log of 2x minus 1 times x minus 1, all of that over x minus 1. And I don't know, that seems fair enough. So that should cancel out. And then he gets, oh, but that's where he made his mistake, right? What you end up with left over when you cancel out the two x minus 1s isn't one of the x minus 1s. You're left with log of 2x minus 1, right? This x minus 1 and this x minus 1 cancel out, and he should be left with just the 2x minus 1 in the logarithm. But instead, somehow, he got rid of the 2x minus 1 and ended up with just an x minus 1 here. So step 3 is where he made his first mistake. Step 3. He somehow intuitively knew that you could divide x minus 1 into this because of, log of a minus log of b is equal to log of a over b. But I don't know, he simplified wrong or something. Who knows? Next problem. All right, let me copy and paste this one too. I'm starting to like this notion of copying and pasting. I don't have to rewrite the problem, and I can mark it up and do all sorts of things with it. All right, a certain radioactive element decays over time according to the equation. Y is equal to A times 1/2 to the t divided by 300 power, where A equals the number of grams present initially. Under number of grams present initially, t equals time in years. If 1,000 grams were present initially, how many grams will remain after 900 years? So we get y is equal to 1,000 grams were present initially, so that's A. So 1,000 times 1/2 to the, and they say, what's time? How many grams will remain after 900 years? T is time in years. So 1/2 to the 900 divided by 300. Right? I just substituted A and T into the equations. They gave us, right? The 1,000 is A and 900 is T. So let's just simplify this thing. So we get this is equal to 1,000 times 1/2 to the, what's 900 divided by 300? It's just 3, right? And so that equals 1,000. What's 1/2 to the third power? It's 1/8. 1/2 times 1/2 times 1/2. And so we get 1,000 divided by 8, which is what, 125. 125 grams are left in 900 years, and that is choice C. Next problem. All right, let me see if I have to copy and paste this one. Yeah, sure, they have a chart, even better. I've copied it, and there we go. Look at that. All right. Bacteria in a culture are growing exponentially with time, as shown in the table below. Which of the following equations expresses the number of bacteria Y present at any time t? Okay, so growing exponentially tells us that, like, if I say, the amount of bacteria after any days, so let's say Y be the amount of bacteria. Exponential form tends to be you have your initial amount, like A in that previous example, times some number that is kind of the exponent factor, I guess you could call it. In the last one it was 1/2. When you do continuous compound interest, it'll be E. But it'll be how fast something is either growing or decaying. And, I don't know, that'll be X. I'm just making up a letter. And then it's usually X to some power T that's usually a function of time. Some constant times time. This is the general form of any kind of exponential growth or decay. You might see different letters in that, but that's the general idea. So anyway, if we said, and if we look at all of these choices, well, if you just look at the thing, you're seeing, it's doubling every day, right? The amount of bacteria is doubling every day. So that tells us there's going to be some power of 2, right? So Y is going to be, the amount of bacteria after any day is going to be equal to some initial amount. Actually, we could just think about it, right? It'll be, some initial amount times 2 to the some constant times the day's power. But I think if we just take 2 to the day's power, let's see. The initial condition, at 0 days you have 100 bacteria, right? So Y is equal to 100. I think this gets you there. Instead of writing days, let's write time. Times 2 to the time, right? Sometimes there's a constant here, but this is straightforward enough. When t is equal to 0, this 2 to the t becomes 1, and you have 100 here. When t is 1, then 2, this becomes 2. 2 times 100 is 200. I mean, you can say this is t, and this is y, right? When t is 0, y is 100. When t is 1, y is 200. When t is 2, y is 400. So it is choice, what is that? Choice B. Probably the easiest way is just to look at these and say, there's only one. Well, 2 of these choices, 3 of them have kind of an exponential form. We're just like, this doesn't take into account the initial condition, right? At day 0, I have 100 bacteria. And this one, I don't know, it says at day 0 I have 200 bacteria, which is just wrong. I have 100, right? You take t equals 0, you're left with what you have at day 0. So depending on how you look at it, you get to B either way. Next question. I'm running out of space. Oh, there you go. All right. Next question. And they write, I'll write the whole thing here. If the equation y to the 2x is graphed, which of the following values of x would produce a point closest to the x-axis? So if you think about it, let's just think about how that graph would even look. So let me draw it here, actually. I'll draw it in a darker color, and I can do it right on top of the white. So let's just get an intuition of how that. What's 2 to the 0? 2 to the 0 is 1, right? So it'll intersect, its y-intercept would be 1 at x equals 0. 2 squared, then 2 to the 2 power, and you were looking at 4. I'll go there. And then 2 to the 3rd power. No, sorry, this would be, this would be, let's say if this is 1, so this would be 2, right? 2 to the 1st power. And then 2 to the 2nd power would be 4. And then 2 to the 3rd power would be 8. Actually, it would be 4 would be like that. So it's going to look something like that. We don't have to worry. It's going to go up really fast. Then what happens as you go into the negative powers? So 2 to the negative 1 power is 1/2, right? So you're going to get right there. 2 to the negative 2 is 1/4, right? So you're just going to get smaller. It's just going to asymptote to 0. So that's what the graph is going to look like. And well, I didn't even have to worry about negatives because there are no negative numbers here. So really, the smallest of these are going to produce a point closest to the x-axis, right? The smallest of these values. We want to get as small as possible. So there's really just, let's see, 1/4, 3/4 is bigger than 1/4. So that's not right. 5/3 is bigger than 1/4. 8/3 is bigger than 1/4. So the answer is 1/4 A. 2 to the 1/4 power is going to be a little bit more than 1. It's going to be something like that. Anyway, next question. Oh, I'm all out of time. See you in the next video.